like the homework that the book gives for this. The reason I don't like it is they give you like, okay, take these 4 problems, do one thing. Take these 4 different problems, do a different thing. Take these 4 problems, do a different thing. I like to give you 4 problems and just have you do everything on it, okay? So it still says 4.4 bookwork on Canvas, but it says 4.4 bookwork / do the problems that I gave you in class, right? So I'll give you those at the end. So that's what you're going to need at least 1 sheet of paper for, okay? The purpose of why I have funny looking graph paper. Yes, I made this just from an Excel document and just kind of made grid lines and copied out what I wanted. I would hold it either this way with the graph up top or this way with blank up top and then a graph. So I would probably do it this way, and I would do a graph and the work for it underneath, a graph and the work for it underneath. If you're a person that likes it in your notebook though, and you don't want to lose these pieces of paper, then at home, you're going to cut out these little graphs and you're going to tape them into your notes, right? Because we're going to use these for 2 sections. And you're going to leave workspace underneath for it, okay? Now, we are going to try to get only 3 graphs done today, right? That's our goal, to get 3 graphs done today. I'm going to try to explain the process of what we're doing kind of very explicitly, because this process is the same for all 6 graphs. So if you get the process of what we're doing today, you will have no problem getting cosecant, secant, tangent, and cotangent with 1 little switch, okay? Once you get better at the graphs, there are definitely places that you can skip, right? Definitely places that you can skip. But again, I wouldn't do that until you get used to it. So you know what? I am going to start a little different order than I did the other class. So I am going to start here. Okay, guys. All right, so we got A, B, C's, and D's, right? So we're doing sines and cosines today. So this is our normal sine and cosine setup. Our A's, B's, C's, and D's are the same as our transformations that we had before. So our A's give us our vertical dilation and our x-axis reflection. Our B's give us our horizontal dilation and our y-axis reflection. C's give us our left and our right, and D's give us our up and our down. Only problem with our C's, right? In order to do a true left and right, just like last time, right? Our C's need to be in the factored form, okay? So factored form. We're going to change some of these words a little bit. And this is how we're going to change some of the words. So our C in factored form is going to be considered our phase shift. That's our left and our right. I would definitely write this stuff down, guys. Right? Our vertical shift is our D. That's our normal up and down. Okay, that's our normal up and down. So those really haven't changed. Phase shift just changes. We use horizontal translation, right? It's just changed to the word phase shift. Our A and our B do have an extra piece with it. Our A is going to find our amplitude. And our amplitude is defined as half the distance between the min and the max. You're going to always be able to find that by finding it by the absolute value of A. So that's our amplitude, absolute value of A. Our B, which is our horizontal dilation and our y-axis reflection, we're really not going to have y-axis reflections in these because they do something weird to the points, okay? that is going to help us find our period. So our period is the length of one full sinusoid. So a sinusoid happens with one trip around the unit circle. So this is a period of a sine or cosine graph. This could also be a period of our sine or cosine graph. So I can start anywhere, I can end anywhere, as long as the beginning starts at the end of the previous period. So I have 2 pi over b here for our period. It really is the absolute value of b. But again, we're really not going to have y-axis reflections. And then there's another part to b, and it's called the frequency. And the frequency is how many times a sinusoid can happen in a length of 2 pi, one trip around the unit circle, okay? So frequency isn't a huge deal. Period is more important than frequency, okay? Any questions on those words? So what we're going to do first is we're going to get you to graph, or I'm going to get you to graph a regular sine function and a regular cosine function so you can see what they look like. Then I'm going to give you numbers for A, B, C, and D, fill them all in, right? We're going to answer these 4 questions and then graph it with its weird, right? So what the book does is they'll give you 4 problems and they'll just ask you what's the amp in all of them. They'll give you 4 problems, they'll ask you what's the period in all of them. Give you 4 questions, ask you what's the phase, what's the vertical. You just do it all in one problem, okay? All right, so we are going to graph sine and cosine first. So again, if you like colors, you might want some different colors on these. Okay, so I have graphs in here somewhere. I don't know where I put them. Here they are. Okay, so we are going to graph a normal sine of x curve. So nothing weird going, no amp change, no phase shift, no vertical change. So this is just what a normal sine curve looks like, okay? So I wrote this on the board because the other class, my little chart wasn't working, right? But if we think of one trip around the unit circle, right? If I start in standard position at 0 radians or degrees, the sine of that is 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's -1. And 2 pi. Would you agree that 2 pi brings me back to the beginning, right? So 2 pi is also 0. So these are the 5 key points of a sine graph. This is the same as a vertical table, right? I don't know why. I just do it horizontally. I'm going to add more lines in the bottom when I do A, B, C's, and D's. I guess I could add more lines to the right, but I don't know. I just like doing it horizontally. If you notice on your graph paper, right, there's no X and Y axes. And that's for when we have A, B, C's, and D's, you kind of have to decide where to put them, right? So right here, this is normal. I am going to put them right in the middle. Now, I made this graph paper. Where we put tick marks is important. So right underneath here, I know you guys probably on the whiteboard side can't see it, right? But you have 30 boxes going to the left and the right, about 30. There's like 32, I think, or 31. And there's 16 boxes going up and down, right? So we're going to utilize that in terms of where we're going to put tick marks. So it takes 0 to 2 pi. The period for one complete revolution is 2 pi. So there's some rules when we're graphing, okay? You need to draw at least 2 periods. At least 2 periods. you need to cross the y-axis, because that's going to give us our y-intercept. And that's really how you're going to tell is my graph correct or not. And then this is my little rule, right? I want you to fill your graph from left to right. I don't want you leaving a whole bunch of empty spaces. So our period, right, how long it takes me to do one complete revolution, 2 pi over b, b is 1, is 2 pi long. So if I make every single box represent a pi, that's probably a bad idea, because I'm going to get 1 period, 2 periods, 3 periods, 4 periods, 5, 6, 7, I don't know, 14 different periods. That's way too, that's the sinusoids way too smushed together, right? So I don't know, on this one, maybe I'll do 8 boxes for pi, maybe. I think that would be good. So when you're putting units on here, you want to put tick marks on where pi over 2 and where pi is. So I'm using 8 boxes for pi. Please don't label every single tick mark because it gets way too smushed together. I need to go 1 more box off of my graph. Totally fine. So I'm going to do it this way as well. Oops, maybe I'm short a little bit. Oops. So right there is going to be 2 pi. So maybe I would have done, have you guys all done it yet so far? I was going to say I was going to change it to 3, right? Yeah. Let's do 3 for pi over 2. So I'm going to change it to 6. And again, just because I had to go off my graph, right? So I'm going to change it to 6. It's not a huge deal if you already did it. You do not need to change it. Why aren't you erasing? Okay, doesn't want to erase that. So I'll just do it in black. Right, so I'm doing 6 units as pi. Yeah, I like that better. So there's 2 pi on either side. All right, so my max is 1, my min is -1. So I'm going to use just something different. 5 boxes for 1. I know it's an odd number, but I'm totally okay with it. Right? 5 boxes for 1. You can use 4, you can use 3. I just wouldn't use 1 because it's just going to be really, really short. All right, so if you guys are using colors, this is probably where I would pick a color for it to stand out. So we're going to plot some points. 0, 0 is a point. I'm going to plot it. Pi over 2, 1. Pi, 0. 3 pi over 2, -1. And then I'm back to 2 pi. Those are my 5 key points that I'm going to connect to make my sine curve. So now I'm going to change colors for my next part. This should have some nice concavity. Right there, the chart. The chart right there. So that should be a 0, right? Yeah. Yeah. Right? So nice concavity, no V-ish graphs. The line in the middle, the points in the middle are called your midline. What type of points are those called when we're talking about concavity? Good. Inflection points. Ailey said it. Inflection points. So that's where your concavity should change. Right? So Calvin's asking, are we doing it on both sides? Right? How many periods do I have right now? 1 period, 1s, right? So all you have to do, right? All you have to do is copy points. So I'm changing colors, right? So all I gotta do is take this midline. All right, if I copy a point, this point's gonna be right here. This point's gonna be right here, right? So then I go max in between these two and a min. So I need a min, I need a max. Well, I think I can do another min over here. I can go off the graph a little bit, and I can do another max over here. Again, I want to fill my graph to left to right. And there's a purpose why I'm doing that. So now I'm going to connect my other points, make a nice smooth curve. And that is my sine graph. So looks like a sinusoid, right? Whole bunch of squiggles is your sinusoid. So if that's my sinusoid, how many periods do I have in that graph? 2.5, right? So I don't have to look at, okay, here's 1 period, here's another period, so that's 2, here's a quarter, here's a quarter. I can just start here and I can say, all right, here's 1 period, it brought me to the start. Here's another period, that's 2, now there's a half, right? So the purpose of the black points is that a sign, key points, should look like an S. So when you do your first 5 key points, it should look like that every single time. Maybe it's stretched out, maybe it's flipped around, right? But it should look like an S every single time. Is that okay? All right, now we're going to do the cosine one. Okay, cosine one. So cosine of x. So I'm going to do the same thing. Cosine of x, 1 trip around the unit circle. So my points are up there, right? Cosine of 0 is 1. Then 0, -1, 0, 1. That's the x's, 1 trip around the unit circle. Try to do something different in this one. Don't put your y-axis right in the middle. Try something different. I'm going to put it a little more to the left. A little more to the left. Doesn't really matter where it goes. I'm going to put my x-axis, I don't know, a little closer to the bottom. And I probably want it in the middle because I'm going from 1 to -1. Totally fine though, doesn't really matter. This time, because where I placed it, oh, actually, you know what I have to do? I have to put it in the middle because I want to do something and I want it to be in the middle as well. The y-axis doesn't matter. It really doesn't matter. You don't have to change it. You'll see what I want to do in a second. Right, so what did I do? 5 boxes before. Again, you can change it, but for what I want to do, I need to keep it the same. How many units did we make last time? 6? Did we do 6? So I'm going to do the same thing. I'm going to do 6. You can do as many as you'd like. I'm totally still okay with that y-axis, though, for what I want to do. So now I'm going to do the same thing. Again, I'm going to use one color for my key points. All right, so 0, it hits at 1. Pi over 2, it hits at 0. Pi, it's at -1. Did I do 6? Did I do 6 for pi? or pi over 2? I did 6 for pi. Thank you. All right, so then I am at here, 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 and okay, so my black points are my cosine key graph. I'm going to copy my points. And I have my cosine graph. Again, cross the y-axis. At least 2 periods. Fill that graph from left to right. Please don't get upset with me if as I'm walking around, I tell you your graphs are a little too pointy, right? Just make them have nice concavity. Nice concavity. Should I be able to take my 2 graphs and land them on top of each other? So if I draw on this one in blue, right? If I draw on this one in blue, right? Drawing on that one in blue, should I be able to take this blue away, copy it, and paste it onto this graph? Should they fit on exactly? Okay, I'm hearing no's and yeses. Okay, should it fit on exactly? Gonna remember, our A's, B's, and C's were all 1s. So should it fit exactly? It's totally supposed to fit exactly. It's supposed to. Here we go. I just went a little off on that one, I think. Right? They should fit exactly. Ailey said no. What doesn't fit exactly? What? Key points fit exactly. I put the blue on top. X-axis fits exactly. Y-axis won't. Right? So if I go back to that graph, right? If I go back to that graph, right? And I put in my y-axis along with it. Right here, my y-axis is hitting at a max. Is my y-axis hitting at a max there? And that's the difference, right? A sine and cosine are just left and right shifts, right, of each other. And you can see that from here. If I take these points, pick them up, and move them over pi over 2, won't they land on top of each other, right? They'll land on top of each other. So a sinusoid, the word, is used for the squiggle of the graph, right? Sine and cosine are very similar, except they're just left, they're phase shifts of each other, okay? Phase shifts of each other. So 5 key points, right? You are looking for 5 key points of a sign to look like an S. Could it look like that? Is that an S? All it is a x-axis reflection, right? X-axis reflection. On our cosine, right? On our cosine one, 5 key points in black look like a U, but I'm going to call it a C instead to remind you cosine. Could I have it upside down? Right? Same thing, x-axis reflection. That's a negative A. Okay? All right, so now I'm going to give you one that has everything in it. Everything in it. Okay, this one. So this is the one we're going to start with answering all 4 questions in going through the whole entire process. Okay, so let's answer the 4 questions first. I want to know the amp, absolute value of A. I want to know the vertical shift, RD. I want to know the phase shift, RB factored out. And I want to know the period, 2 pi over absolute value of B. All right, Luke, what's the amp? Absolute value of A, 3. So the amp is 3. So that means between the min and the max, the distance should be 6, right? Half of that distance is 3. I would definitely be on a nice side that you got an empty graph, okay, and some work. Okay, how about vertical? Faith, what do you think? Up or down by how much? Down 4. So remember what I could say, right? I can say down 4, or I could say the vertical translation is -4, right? Andrew, how about phase? I'll give you a hint. It's not right pi. Nope, I'm still going to go for right. I just need that factored. So how do I factor it so that it looks like that? Pi over 2. So 2 over 2 is 1. Pi divided by 2 is pi over 2. So right pi over 2. Cole, how about period? 2 pi over B. What's my B? Goes right in order, A, B, C, D, 2. So 2 pi over 2, pi. My period is pi. It should take pi units for 1 complete sinusoid to happen. Okay? You are going to be able to check those. Okay? You're going to be able to check those. So process that we're going to use, right? These key points that I have on the whiteboard over here, right? One of the periods today, it wasn't working. So as it's not working right now, right? So these are our key points. Again, it's not coming out. Don't know why. It's supposed to unhide there, right? But those are our key points. 1 trip around the unit circle. Those key points are important, okay? So those are the key points that we're going to get the S or C with. So we're going to have these 3 steps that we're going to do. We're going to do B and C first. What B and C are going to give us is it's going to give us, I think I'm spelling convenient wrong, I-E-N-E-E-I, convenient. That looks right, right? The B and C is going to give us a convenient place to graph, a convenient place to get 0, 1, 0, -1, 0, right? Then we're going to multiply by A, right? This is going to look at the amplitude, and that's going to change our vertical stretch and shrink. And then we're going to look at D. So we're going to use B and C first. Then we're going to use A. Then we're going to use D. Okay? So again, if you guys get this process, it's going to make all the other ones really easy. All right. So first thing I said we were going to do, get our most convenient place to graph. So normally 1 trip around the unit circle starts at 0 and ends at 2 pi. 1 trip around the unit circle. Nobody usually argues about that. But I'm going to change it by giving it a horizontal stretch and or shrink and a phase shift. So what you're going to do is you're going to take that B and C part, factored or unfactored, it doesn't matter, and you're going to put it in between 0 and 2 pi. So we're going to make 2 changes. We're going to make the phase shift change and the horizontal dilation change. Calvin, what do I need to do to get X all by itself in the middle? I want to get X all alone. So how do I isolate X inside there? How do I get rid of the 2 and the pi? Add pi everywhere first. And then what was the second thing you said? Divide by 2. So if I divide 2 by everywhere, this is telling me the most convenient place to graph this function is between pi over 2 and 3 pi over 2. That's going to get me 5 key points. Okay? So now let's see. I think I can check these 2 bottom items. All right? I think I can check those. So normally it starts at 0. Now it's telling me to start at pi over 2 instead. Well, is that a right pi over 2 change? If I was supposed to start at 0, now I'm starting at pi over 2. Is that right pi over 2? It is. Normally, it takes me 2 pi units to make a full trip. Well, now, what's the distance here? What's the distance between pi over 2 and 3 pi over 2? 1 pi. That's how long it's going to take me to make one full sinusoid, and that matches with the period, right? So that's where the check of those 2 things are coming in, okay? All right. So now what we're going to do is we're going to make a little table of values. So I already took care of the B and the C. I'm going to need a little more room. I already took care of the B and the C. Okay, so I'm going to do a nice little chart. I need 5 points. 1, 2, 3, 4, 5. So this is telling me to start at pi over 2. It's telling me to end at 3 pi over 2. So just like these 5 key points, right? They're all pi over 2 units away from each other. I need to find some midpoints. So if this is pi over 2, right? That's pi over 2, and that's 3 pi over 2. Paulina, what's the midpoint between pi over 2 and 3 pi over 2? Pi. Pi is the midpoint. So pi is going to go in the middle. Midpoints again. Pi over 2 and 1. Rocco, what's in the middle of that? Pi over 2 and 1. Think about it. 50 cents and $1. 3 pi over 4, right? 3 pi over 4. So this one is usually the hardest, right? But watch what happens. A pattern actually happens. This is 2 pi over 4. This, whoops, I erased it, is 3 pi over 4. This one is 4 pi over 4. This one is 6 pi over 4. What's this one? 5 pi over 4. It always jumps by the same. Always, 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 always. It doesn't have to always jump by 1, but it always jumps the same. It could jump by 7 on each of them, but it always jumps the same. Okay? So we've got the 5 key X's. All right, here's where you have to really pay attention. So you got to use some unit circle rules here. All right, I've got to take these 5 X's. I have to plug them in here, and I need to find the sign of them. So Gabrielle, if I take pi over 2 and plug it in right here, what's 2 times pi over 2? Pi minus pi. What's the sign of 0? Nope, sign of 0 is right behind me. Sign of 0, I'm on my positive x-axis, is 0, right? Let's do the easy ones first. Let's do this one, pi. Garrett, 2 times pi minus pi. What's the sign of pi? Yeah. All right, Hayden, you got the last one. 3 pi over 2. 2 times 3 pi over 2. Nope. 3 pi. 3 pi minus pi. Sign of 2 pi. 0. Well, that's kind of weird because on the first one, didn't I get 0? On the second one, didn't I get pi? On the last one, didn't Hayden just get 2 pi? What do you think the answers to this one and this one are going to be? Same thing. So you never, ever have to do what we just did. Never, ever, ever. You never have to take those 5 points and plug them in, because it is always going to be 0, 1, 0, negative 1, 0. Always, 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 when it's signed, right? But again, I like having you guys do that. So you're like, oh yeah, those are the points that we just got, right? Because all we did is move it left and right? And either stretched or shrunk it horizontally. All right, so now I'm going to multiply by A. So our A is 3. I'm multiplying by 3. And I am adding our D. I'm subtracting 4. So negative 4, negative 1, negative 4, negative 7, and negative 4. Drives me crazy when it changes red and black. So there we go. That's the best place to graph this. Pi over 2 to 3 pi over 2, and here are your y's. So now we're going to go in graph, right? So we're going to decide where to put our x and y axes. X-axis, that's an easy one. Look at your mins and your maxes, and actually we can check this too, right? Isn't our max at negative 1? Our min at negative 7? What's the distance between negative 1 and negative 7? 6. What's half of that distance? Isn't that what we said as the amp? Right? We said the amp was 3, right? What else did we do? Down 4, right? Down 4 is going to be the midline. It was at 0, and then I moved it down 4. So that checks that too, right? Down 4 is our midline. Where do we want the x-axis? Right in the middle, high, low? Where do we want it? High, right? Because we got negative 1 to negative 7. So I'm going to do a little higher x-axis. Right? Little higher x-axis. How about our y? Where do we want our y? I'm going pi over 2 to 3 pi over 2. We could put it right in the middle. I'm going to put it a little to the left. Right? Just so, again, we're kind of changing it up a little bit. All right, so since I have my y-axis in there, the easy part's always my y-axis. I'm going to do, I think I have enough, right? Again, 16 units from the top and the bottom. I think I'm going to have enough for every 2 boxes to be 1. Yep. So again, don't label everything because it gets way too confusing. Just put your tick marks, right, and label where 1 is. All right, here's the important part, right? My period is pi. I want you to make at least 2 periods. The easiest way to determine the number of boxes for pi is to do a common denominator of your x's. So a common denominator would be what? 4, right? But let's just figure it out for a little bit. If I make 4 boxes for pi, that's how much a period is. If I have 30 boxes, well, what am I going to get? 7 plus periods in there, right? That's a pain. So you're going to use 4 boxes for pi, or 8, or 12, right? I'm going to do 8. And the reason I don't like 12 is because if you think of 12, pi over 2 is going to be 6, right? And then pi over 4 is going to be 3. Odd number of boxes usually creates issues. So what did I say I was going to do? 8? Yeah, I think I said I was going to do 8. So that's going to get me 3 plus periods. So I'm going to do 8 units for pi. It is important where pi is located. So you don't really need to label these units right here. You don't need to label these x's. You need to know where pi is, okay? So now again, one color for those 5 key points. At pi over 2, it's -4. At 3 pi over 4, it's -1. Pi, it's -4. And I'm going -7. And then I'm going back up. Do those 5 key points look like they should as an S for our sine function? I was saying last class, I like this graphing. It's like we're drawing pictures. It's fun. It's relaxing. Are these points on here that you're making, or are these just the tick marks? Okay. I'd be careful in just doing like that as a point. If you want to make it a tick mark as like a line, that would be better, right? Yeah. And again, you don't need to label every single one. You need to just really label where pi is, just because you can have so many tick marks on there, right? And again, not as V-ish, guys, not as V-ish. You want it nice, rounded. Okay, does it look like the way it's supposed to? Is it an S? Right? 5 key points, you're supposed to have an S, right? So now you need to copy your points left and right, fill them all in, right? The way that I fill them is I go to the midline first. It looks like I'm going to skip 3 boxes and then put a point. Skip 3 boxes, put a point. Skip 3 boxes, put a point. Whoops, I can't get right there. Skip 3 boxes, a point. Skip 3, a point. So say it again. I'm skipping 3 lines. 1, 2, 3. 3 lines. And I'm going max, min. So this one's got to be a max. This one's got to be a min. This one, I have a max. This one's going to be a min, a max, and I can do one more min. Again, you really don't have to do the different colors, right? But I'm just trying to have you look, do your 5 key points look like they're supposed to, right? And those 5 key points look like an S. So again, don't get mad at me if I tell you too pointy, just fill it, right? But that is your curve. Why are you saying something's wrong? It looks like it's too wide, right? It looks like not enough of space in between, right?
Yeah.
So you just didn't do your point in the middle of the next tick mark.
Okay.
Right? Because you didn't do it over 4s.
Oh, yeah.
Right? So that one should be right there.
Okay.
That's why it's important to do those first 5 first. So pretty, right? Little pointy, right? Just at the points, you're a little pointy, right? Just want it more curvy, right? So you were short a period a little. No, you're okay. Because look, this one can fill in here, right? And you got 2. So again, maybe a smaller dimension would have been a little better. You're totally fine though, right?
I messed up one of the points.
Okay, so how many periods do I have on my graph? How many periods do I have on my graph? How many? I think I have 3 3/4, right? I'm being picky, right? Because I went all the way to this point. You kind of can't see it, right? But I did go all the way to that point right there, right? So 3 3/4, right? Again, I just want you to get used to how many periods you're actually drawing. Okay, is that good? Process okay? If you understand that process, this whole section will be nice and easy. All right, let's do a cosine one. Oh, sorry, I just want to look at the numbers that I used on that one. 3, 2, -1, -4. 3, 2, -1, -4. 3, 2, -1, 3, 2, -1, -4. All right, so I was just trying to do all the relations, right? So I was trying to do a whole number for an A. Now I got a fraction, I got a negative. I was trying to do a left, a right, an up, and a down, right? Let's answer those 4 questions together, right? I'll go easiest to hardest. Faith, vertical. Oh, I think I asked you vertical last time too. Up to. So our vertical translation is up to. All right, I think the next easy one is amp. What's our amp? 1/3 positive, right? Amp is always positive, so 1/3. Phase is a little tougher. I think period is easier than that. Period, 2 pi over b. Joshua, period, 2 pi over b. 6 pi, 2 pi over 1/3, 6 pi. How about phase? Phase, right? You've got to take out that 1/3. This time it's actually 6 pi again, I think, right? So I'm taking the 1/3 out. I'm factoring it. 1/3 divided by 1/3 is 1. That's the purpose. 2 divided by 1/3 is 6 pi. So left 6 pi. Or I could have put minus 6 pi. All right? You guys try to go do the points. Try to do the points. Try to break up your x's. 0 to 2 pi, 0 BC 2 pi. So you're going to go 0, less than or equal to this, less than or equal to 2 pi. So write that.
And then you solve for
Yep. Yep. Again, once you get used to it, you're going to be able to jump to that nice interval so easily. 2 pi, 0 to 2 pi. Remember, 1 trip around the unit circle. If you guys don't like the fractions, right, just multiply by a common denominator and it will make it easier for you. If you don't like the fractions, get rid of it by multiplying by a common denominator. Let's check your location. -6 pi to 0. Is that right? Leo, how can I check myself? If you're telling me -6 pi to 0, how can I check myself? How can I check myself? Is that bringing us to -6 pi? Right? So again, normally it starts at 0, but left 6 pi is telling me left 6 pi. Is the period 6 pi? It is, right? So that's how you can kind of check yourself. You look at the phase, you look at the period, you see if it matches. So really think about how many units for your X and Y axes. Totally. Are you going to tell me what's the midpoint in there?
what? -4.5.
Yeah, and -1.5, right? It's totally fine. You can put 0.5. Yeah, you can put 0.5. On these, when it would be like 0.5s, like with a hole, you probably don't want to put like 0.75 pi. That's kind of weird, yeah. But like with this, because it's so large, you're not going to make so many units for pi. So this one, it wouldn't be bad. Yeah. What do you get? -1.5, -4.5, right? -1.5 is totally fine. -4.5, totally fine. What are you saying, Cole? You would divide by 1/3 first because of this guy? I would actually use this one. It's easier. And I'd subtract 2 pi first. And then isn't dividing by 1/3 the same as multiplying by 3? Yeah. Yep, cosine, guys. Yep. This one's cosine, so make sure you're using 1, 0, -1, 0, 1, right? This one is cosine. It's always, well, think about it. Isn't it taking this, multiplying it by A, and then adding D? I think I added, didn't I? 1, -1/3 plus 2 is 1 2/3. Oh. 0 plus 2, right? Yeah. I added, right? So again, decide how much you're using for some boxes, 4 pi. It's looking like a birdie, right? So what's, okay, so see, can I borrow your pencil? I think there is something wrong with it because you're saying the highest is this, which is 1 unit away from the midline. And you're saying the lowest is this, which is 4 units away from the midline. That's wrong. It's supposed to be the same. The midline is supposed to be in the middle, right? So let's see. 1, 0, -1, 0, 1. You didn't multiply by -1/3. Oh. I don't think that's the problem, though. -1/3, right? And now I have to add 2. So one, that could have ended up making it a problem. So I think that's -1 2/3. -1 2/3. 2, 2. And what's this one? 2 1/3. Right? Add 2, add 2. So now if you look, right, here's the midline. This is 1/3 away. It's going to make sense. This is 1/3 away. It's going to make sense, right? So see, like even drawing it, you knew there was an issue, right? So the midline should be in the middle. Because you didn't add 2. Adding 2 would be 1 2/3.
Oh.
Right?
Oh, I forgot. Oh, wait. No.
Yeah, I got a 1 there. Well, I want my graph to be like that. Because I want to have a conversation. Shut up.
I already started.
Totally fine. You're totally fine. Throw it the way you want it. I'm just having a conversation. You are totally fine. You guys are both totally right. I just want to put a conversation, right? So as soon as I put those lines up there, my x-axis and my y-axis, I got these 4 guys yelling at me, right? I got these 4 guys yelling at me and telling me I have an issue, right? I want to have a conversation, right? So in terms of me putting those lines where I put them, am I wrong? No. Are you wrong? No. We're both totally okay, right? So look, Gabrielle put them in the middle. You guys put them on the left, right? I'm sorry, on the right. You guys put it on the right. You guys put it on the right. I probably would put it on the right normally, right? But I want to have a conversation because I put it here. I started my graphing. I'm like, oh no, I don't have enough to go to the left 6 pi. No big deal, because isn't this the end of the previous one? Isn't this the start of the next one? Right? Doesn't that make sense? So I'm okay. 0 is going to be 1 2/3. Right? So then I'm going to jump to 6 pi. Right? Because if I take these points, -6 pi to 0, and just copy them over, won't they be the same for 0 to 6 pi? Does that make sense? Right? So what did we use? I think I used 2 units for pi on this one. Right? So at 6 pi, oh, hold on. At 6 pi, it's also going to be 0. You guys did fine on your graphs, right? Here is your homework, though, right? You guys got to take a picture of this on your way out, or it will be on the recording, right? Your homework is going to be these 4 graphs and answering these 4 questions. Graph and questions. Make sure you are leaving with 1 sheet of paper. You do not need to do book. You need to do those, and I'm pretty sure I need to change the date. They are due next class. You can just take a picture or they're on the recording.
Is this going to be the C? Or?
Is this going to be the C? Is this -6 pi?
Yeah.
It should be. What does that say? 5/3?
Yeah.
You have an issue. You have an issue because you're telling me that 5 boxes represent 2. Are 5 boxes bringing me to 4? And that's why I want you on grid paper, because usually that happens this way.
Yeah.
So you don't want to necessarily put units that belong here. You want to put the 1s, the 2s, the 3s.
Yeah.
So that could be why it looks off a little bit. Okay.